Yeah, I don't think I'll match that. I must admit up front. And I hope, let's contract on time. I was supposed to finish in the next 3 minutes. Yes. The topic I was given is to reimagine universal access using renewable technologies. But I'm just going to summarize a few ideas that I just want to share with you. And firstly, let me see whether I can. Now, I think the first idea, which I think has been the revolution for humanity, is the idea propagated by Michael Faraday in 1831. A very powerful idea. And up until then, electricity was non-existent or was an area of interest, but of no commercial value. But Michael Faraday, let me check how many electrical engineers in the room, just to make sure what I say can be confirmed by some colleagues here. I think this simple idea or powerful idea discovered by Faraday was that if you move a magnet in an electrical coil, you get current. And if you do the opposite, if you move electrical current that interfaces with magnetic field, it creates motion. Now that idea then created electricity generation and the electric motor, and that transformed humanity. And it also, for the first time, gave us the possibility to transmit energy at the speed of light. One of the fundamental things about electricity, unlike any other form of energy, is this ability that today, as we sit here and we switch on the light, that light may be caused by coal being boiled or being burnt 2,000 kilometers away this instant. It could also be caused by water falling in the Kawarabasa this instant, but we can use it here. And that just transformed humanity. And in fact, when Chris says, you need to leave your option open, I can say probably for the next 100 years, this Michael Faraday idea of electromagnetic induction will still be part of human progress. And I think that's, for me, the fundamental issue. Now, coming home to South Africa, this is the man I've studied for a long time, and I came across this man when I was in trouble at Eskom. Maybe let me just talk about my journey. Say, I'm an electrical engineer by training. When I decided to do electrical engineering, I had not met any electrical engineer in my life. I come from a small village in Limpopo. I happened to be quite fortunate in around 1978 to get a bursary of Anglo to do electrical engineering. And I chose it because the bursary advert says you're going to get a stipend of 300 rand per month. And that was a lot of money for me, and I took it. But I didn't know what electrical engineering is. So my journey took me to Anglo, to the mines, to ACI, to Sasol. Then it landed me at Eskom, where I spent 15 years. I became the chief executive of Eskom, and until I left in 2009. So around 2007-8, when I was the chief executive, when I got into trouble in introducing the first load shedding in South Africa, I began to ask myself, people before me, how did they manage this? Then I began to study the people who have managed and led Eskom, and it led me to this man called Henri van der Bijl. And I actually became a devotee of Henri van der Bijl. But beyond Henri van der Bijl, let me just talk about somebody else who mentored Henri van der Bijl, who in 1895 alighted out of a ship here in Cape Town, fresh from Cambridge University. And around October of that year, he was making a speech, his first political speech in Kimberley, in support of one of the most powerful people in South Africa then, Cecil John Rhodes. This young man, aged 25, stood in Kimberley, and he was asked to come and talk about the political situation in the Cape. Then this young man says, no, the political situation in the Cape is a small topic. I want to speak about a bigger topic. I want to talk about the next 25 years of South Africa. There was no South Africa then. It was colonies of South Africa. But in particular, I want to talk about the consolidation of the white race, and I want to talk about the relationship of that white race with the native race. But in that speech, which was about an hour, he spoke about things, when you look at the history of South Africa, that took 50 years to manifest. The Union of South Africa, the development of the minerals in South Africa, the political situation, the foreign affairs of South Africa in relation to the West, particularly to Europe, but also spoke about what it means to develop South Africa from an industry perspective. That was 1895. That young man, Jan Smuts. 1910, he becomes one of the most important people in the 1910 Union of South Africa government. I think he had 3 portfolios, one of them industry, minerals. Then he asked himself the question, what should happen to integrate South Africa into an industrial power? Then he called Hendrik van der Bijl, who was then a scientist working in America and Europe, and he asked Hendrik van der Bijl, Hendrik, how do I turn South Africa into a modern industrial base? And Hendrik van der Bijl says, integrated power, integrated transport, steel, funding. Then Jan Smuts says, go and do it. So in 1922, he then started Eskom, he started ISCO, he started IDC, and then he inspired others, industrialists, who then built Sasol, Fosco, Amsco, etc., etc. Now, why is this important in the context of today? It is important in the context of today in that, in my view, what we have as South Africa's industrial base didn't fall out of the sky. It was something that came out of a clear plan, and with people deployed, and here I'm going to use the word that I think people don't like now, cadre deployment. So Jan Smuts actually deployed his cadres, and one of the brightest cadres was Hendrik van der Bijl. But the cadre deployment was different in that it was based on deep education, deep loyalty to the country, and also given space to do what needs to be done. Now, in the context of electricity, which is the subject of today, Hendrik van der Bijl motivated the 1922 Electricity Act. The Electricity Act of 1922 was very simple. It was to say, provide electricity across the country, wherever is required, cheap, but at no profit, no loss. That 1922 Electricity Act built the industrial base of South Africa. It brought in the ability to develop the minerals of South Africa, the transport network, farming in South Africa. It was so effective that from 1922 up to 1985, the entire power system was built on what I would call the Hendrik van der Bijl formula. And in 1985, we had a problem. We tried to change it, and I want to suggest that since we tried it since 1985 to today, we've not been able to find an electricity funding formula as effective as what we've seen with the 1922 Electricity Act. Now, I say this because I think it's important that, because currently with load shedding, with political situation, we can become too short-term about the solutions. Because when you look at the Hendriks van der Bijls and the Jan Smuts in building what I would call, even today, the mold, the industrial mold of South Africa is built out of the 1910, 1920 decisions. It was use the minerals to industrialize, use the state-owned enterprises as the platform. And that what builds South Africa. But also, which is important, and I think we need to admit it here, use state-owned enterprises to uplift the Afrikaner and to create an industrial class out of the Afrikaner. I mean, we know prior to that, the Afrikaner was the farm-bound community, but you go from 1910 to 1950, they transformed themselves to become world-class industrialists, to build things like Eskom, which became not only just minor entities. I mean, Eskom became the 10th largest utility in the world. We talked about nuclear. We became a nuclear power. Not only nuclear energy, we built the bomb. You go to Sasol. We took a small pilot technology to transform coal into gas. We industrialized it, and now Eskom is actually taking international. When we built power systems, we went, I mean, in terms of transmission grids, we did some of the biggest things, highest voltages, high HVD, high voltage direct current. So we did big stuff. And I'm saying we, and I'm mindful of saying we, because I believe that history is a balance sheet of a country. So when 1994 came, in my view, whatever history we have before 1994, we expropriated it without compensation. Because for me, history is like a balance sheet, right? In a balance sheet, there's assets and liabilities. Some of the bad stuff are liabilities, but there's some good stuff in the history which are assets which we need to build on. And I think when I look at Hendrik van der Bijl, I'm expropriating him as an engineer, as a scientist, because he's an asset in terms of what we can do. Now, why is this important when we look at going forward? And this is the criticism for me of the current situation. We are in crisis mode. We are trying to solve the current pain. And I can say for the past 15 years, we've been trying in the energy system to solve the current pain. Now, people will come tell you, the current pain can be solved with renewables, so let's do renewables in 24 months will be, right? Then also, maybe to come to some of the people, some of the countries that we need to learn from. Those that when they started their transformation, they looked many years ahead. China. South Africa, in terms of industrial base, was far ahead of China when China started its development. South Africa's nuclear base, nuclear power, and when we had nuclear power, China didn't have nuclear power. But in 40 years, China is second in the world in terms of GDP because they looked far ahead. And for me, that's the thing that I think as we look back in this history of South Africa, but also at where we need to go in the energy space, is to begin to think about how we look 25 years into the future and come back and say, what do we do now? So from Hendrik, I go to Comrade Madiba, 1994. I got involved in electrification. I joined Eskom in 1995. Before that, 1994, there was a clear intention that we need to electrify the country because at that time, only 30% of the people were electrified. So the idea, there was an RDP target to go to 1.7 million by 2000. That meant 3,000 connections per annum. What we needed to do is both the technology and the cost to do that. We brought in prepayment meters. South Africa, at the time, prepayment was nowhere. We brought prepayment, and we brought access from 30% to 90%. Prepayment moved out of electricity into telcos. Now, the MTN adopted it, and some of the MTN guys actually came out of Eskom. So that was a big deal. But I think we have hit a speed bump. a very big speed bump in electricity. One, cost. And in my view, the cost is because we ditched in 1985 the Hendrik van der Bijl formula, but we never replaced it with anything that works for us. A lot of people talk about pricing of electricity. We have not found a formula that works for us. So what has happened from 2007 to now, 700% in increases of prices. I think we've had recently about 35% again. It's a spiral because we have not hit the formula in terms of electricity. Of course, load shedding. You ask me, what are the causes of load shedding? I think we want to be short-termism. But in my view, is the whole formula in the electricity sector is broken. And you can bring solar here or there. But if you don't deal with the fundamental problem of fixing Eskom, we're going to be in this situation for a long time, in my view. And we need to support Eskom to deal with what they need to deal with, to be able to deal with load shedding. Now, beyond load shedding in the township, there's a concept called load reduction. And I don't know whether it happens in the Western Cape. But here is beyond load shedding is where communities actually switched off because there's lots of illegal connections and the grid cannot handle it. So they switch them off for hours. And in fact, people are beginning to complain that that is actually energy apartheid. So we have connected people. We have brought people to 90% in terms of connection. But because of, one, the cost, it becomes a problem. Two, load shedding and load reduction. Now, the other speed bump is climate change, and we happen to be, our base is 80%. So we need to be mindful of that. Lessons from Europe, in short, Germany was more aggressive in terms of this journey from moving from fossils to renewables. Past 20 years, in rand terms, they've spent about 8.5 trillion to try to move from fossil fuels. And it looked that it's going very well until Putin unplugged the natural gas. And the entire Europe went into an energy crisis. And it's not only about renewables alone, but there are many other things. And in fact, just to mention one big issue which we need to be very, very careful about. In Europe, they've got a electricity pricing system called the marginal pricing system. Or put another way, it's called the, I'll remember the other way, but the marginal pricing system works the following. Every day or every period of pricing, all technologies bid their price into the market, from the cheapest to the most expensive. So you continue pricing, and the one that closes the market, that is the one technology that then makes sure that supply is then satisfied for that period, sets the price. Right? So what it means is that if you've got your technology at 1 rand, right, and the one that closes the market is at 10 rand, 10 rand becomes the market price. So even if you bid at 1 rand, you get the 10 rand. Right? That's the marginal pricing. Now, the reason for the crisis in Europe is the technology that closes the market is gas, and gas has become very expensive because of Putin. Prices in Europe went up to almost 1,000% increase because of that. So those are the kind of things that I think as we move forward, we need to learn and manage. But what we need to say about Germany, I think, in terms of the legacy of Germany, is that they really put renewables on the map in terms of technology. And in fact, the complementary thing that actually also happened is that China adopted renewable energy as their industrial strategy for the future. For the past 10, 20 years, China has been figuring out how to produce renewables cheaper in volumes. And they've done a stunning job. But in doing that stunning job, they've captured close to 90% of the market. any PV or solar PV that we buy, 90% of the time it comes from China, because they do the cheapest and quality. So they've given us that gift. The consequences of that is the prices of PV has come down significantly. In 2013, we started our IPP. Currently, I mean, then I think we're buying PV at about 4 rand. I mean, currently PV is even less than a rent. That's how, you know, significant that is. Now, that opens a lot of opportunities for both commercial, industrial companies and also residential customers. And in fact, today, if you're a commercial customer, you've got roof space, if you're not putting solar PV on your roof, you're actually losing money, because the price of PV compared to Eskom is such a big disparity that, you know, you'll save money very quickly in putting PV. So it's important to understand that dynamic. Now, I'm not going to go into this, and I think my colleagues, Chris and Calvin, have talked about the options in terms of the new paradigm of universal energy. Because whereas electricity and the wire coming into your premises was the only thing, now I think many opportunities have opened. I mean, we have solar, battery. Now, in terms of residential, gas heating, you know, gas heating becomes a possibility. Now, I'll conclude with this slide and maybe leave a few minutes for questions. So where we're playing, we as Organized Energy, we play in the total space. We play in utility scale, we play in commercial, industrial, but we also play at residential, you know, normal residential, but low-income residential as well. At the low-income residential, as I've indicated, the biggest issue, load shedding and load reduction, and also affordability of electricity. Now, with these new technologies that are beginning to come, many possibilities are beginning to open. And it's also our collective responsibility in the industry to begin to see how do we deal with this. Because electricity and infrastructure, for newly enfranchised people, the meaning of democracy and liberation can only be realized when you access this thing in an affordable way. So when a thing like electricity becomes unaffordable, then the meaning of democracy becomes very hollow. So bringing solutions into this market, bring to democratize energy, brings power to people. The possibility that you could start beginning to put solar on your roof and sell back. In South Australia, almost 40% at some point during the day, they run from rooftop solar. That's how powerful the incentives of incentivizing people to put solar and sell it back to the grid. And what it could mean if priced correctly for the low income when your roof becomes your energy business. Just energy financing, one of my colleagues likes saying, you know, every time he looks at the issues of solar and low-income households, is that, I don't know, some of you probably remember, but in the townships, when we grew up, there were few people who had television, you know, who can buy television and will sort of gather and watch the televisions because we didn't have. But a company called Teljoy came and brought a model where you don't have to put up the capital. And all of a sudden, television access becomes very big. Now, those are, for us, the things that we need to be looking at as just energy financing, to actually begin to bring cheaper solutions to households. The please call me of energy, we don't know where that's going to come from, where somebody comes with a killer app and begin to help low-income communities to deal with energy. The concept of township energypreneur, not tenderpreneur, but energypreneur. Now, together with this, we are looking at other solutions like standalone sewer treatment, water recycling and reuse, and also beginning to challenge to say, in this current energy situation, universities need to bring their thought leadership, not only to solve the big problem of utility scale, the big problem of ESCOM, but to say, how do we make it real to everyone and actually bring energy democracy to everyone? So with those words, I'll stop here, and maybe if there are questions, I'll wait for questions. Thank you very much.
I'm in a bit of a quandary now because the other two guys didn't have questions, but let's say we take 3 questions. First with Jacob, if there are more from him, then we'll extend. And then I just need to make a deal with you. We have too many speakers, but we wanted to give you quality and quantity. So I'm proposing the following. We've had lunch less than an hour and a half ago. That after the questions, we proceed with the other 3 speakers, and then we go for a break row by row, like the airlines, you know. So the first row goes out, do what you want to do, get coffee, come back, and then the second row, so that we can carry on. Otherwise, we'll miss our cocktail, and I wouldn't want you to do that. Is that okay? Can we agree on that? Okay. So you have a break. Just wait. We start at the back row, and row by row. I wouldn't get a stewardess to, please, there's no stewardesses to tell you to go, but just watch out. So, first question there, sir.
Hello, is it on?
Yeah. Yes.
Okay, questions for both Chris Yelland and Mr. Maroga. In both cases, I agreed with them 80% of what they had to say, disagreed on 20%, just one part of the 20%. Solar and wind is very, very good for off-grid applications. Excellent. We've seen a whole lot of them. Chris Bosch gave good examples. And you gave good examples. But for grid electricity, for national grid electricity, they are absolutely useless. They've been proved a complete disaster all around the world every time they've been changed. Germany is a brilliant example. Britain, Australia, every single time it's been tried, it's always been the same result. The price of retail electricity goes up and up and up. So you've got energy poverty in Germany, one of the richest countries on earth. In South Australia, which you mentioned, they went from coal heavily into renewables. The result was the price of electricity soared up, and they had 2 total state blackouts. And the reason is this. You had a graph, Mr. Maroga, showing the price of PV coming down. That electricity there is electricity as it leaves the solar panel. For the national grid, that's useless. And to turn that into useful electricity, you need backup, you need reserves, you need spinning reserves, a whole mass of things that are very, very expensive. I would say you add at least 200 cents a kilowatt hour onto whatever price you give for solar to get the actual price, the full cost of electricity. So if they say, right, the solar electricity is 25 cents a kilowatt hour, you can know that the full cost is actually 225 cents a kilowatt hour, if not more than that. Thank you.
Jacob, Chris.
Yeah, I don't think it's a question. It's more a comment. I don't want to debate because I think some of the technical things you're saying are quite correct. But what I won't say categorically, whether we shouldn't do utility scale renewable. And the issue is how we price it, how we integrate it, because if you put a lot of area of renewables as complementary to the grid, you can still get benefits of non-emitting technologies coming into your grid. But where I agree with you is unplugging coal now and just putting renewables, technically for me, I disagree with that. So things like battery storage, hydro storage needs to come in to be able to actually begin to complement renewables. So I'll
Chris, briefly.
Yeah, just to reply to the question, the gentleman there, Mr. Kenny, suggested that nowhere in the world does a grid-connected solar PV or renewable system work. That is just not true. We have grid-connected solar PV all over the world, including South Africa. And anybody here who's got a rooftop solar PV system, the last thing I'm suggesting is to go off-grid. That is the very worst thing you can do and the most expensive thing you can do. But to suggest that grid-connected solar PV systems with battery storage don't work is just not true. We have from the largest systems, hundreds of megawatts, to the least. Around the world, we're talking about 1 gigawatt, 2 gigawatt, 5 gigawatts of solar PV systems grid connected. To say they don't work anywhere in the world is simply not true. And the other thing to answer to Jacob, I agree with you entirely. Nobody that I know is suggesting that we switch off coal tomorrow. Nobody that I know is suggesting that we must shut down Koeberg tomorrow. The question is about new generation capacity. Do we build new coal? No, it's not financeable. But that doesn't mean to say we must switch off coal-fired power generation tomorrow. Thank you.
You remember Jan Oberholzer? I think what the gentleman meant was that overnight, unless you have good battery storage, solar and wind is not existent. I think that's what I mean, but with battery, obvious. Could I ask, Jan Oberholzer said, Jacob, he spoke about, he didn't call it base load, but he showed there that the base load that we need on the grid cannot be given by solar and power alone. You need coal and nuclear. Now, Gideon Gravenstein, who's sitting here, who was head of the PBMR project at Potch University at the time, Northwest, said to me, and I won't embarrass him, that he does think that if we have a smart grid, that you have solar from different places and different times, it could extend the base load on the grid, even with solar and wind. Would you agree with that?
Well, firstly, let's just go to the fundamentals.
Yes.
Wind and solar by themselves are what is called intermittent. You cannot detect where, when they're going to, to transmit or to generate. But there is solar where you could track the sun. That gives you more yield. But with digital technologies, we could begin to aggregate. That aggregation gives you more predictability. Right? So those technologies are going to emerge. But we're not there yet. So we should accept. Okay. And for now, the biggest thing that you could do in terms of solar is battery storage to make it dispatchable. Or some people do hydro storage, pump storage. So until those technologies mature, where we can actually make solar and wind more dispatchable, we can't just unplug the current dispatchable coal or whatever you have. That's why in Europe, basically in Europe, the biggest thing that happened in Europe was that they switched off their coal and replaced it with natural gas. And that natural gas happened to come mostly from Russia. Right? Of course, there's some countries that has got more storage, but the biggest replacement of coal in Europe was natural gas. Right? Okay. So until we have storage, matured, that's why people talk about gas as a transitional fuel until we find something else, a more dispatchable. Yeah.
One more question. No one wants to take Kelvin on? Thank you. There is one.
Mine is on the emerging opportunities, the democratization of energy, that is power back to the people. Mine really is to say that, we need to define what we mean about that. We don't want to repeat the mistake of saying, back to the people and creating more problems. Because what happens is that we know, you talked about the speed bump of load reduction. which is caused by people, you know, doing the illegal connections and stuff like that. So we need to really look at the source. What makes people, you know, come to the cities, right? In South Africa, we have experienced, you know, urbanization, people running away from the rural communities because they think that there's a green pasture in whatever city. And as a result, we have this load reduction, right? And what happens now when the government or whoever comes with a solution, they don't do the definition of what that solution means. So we need to really go to the source. What I would then suggest would then be to look at where people come from. You know, doing it yourself. I like what Chris said when he was presenting, where he said you must have a global look, but act locally. So which means then that you will need whatever solution, whatever you bring back to the people is going to the local, you know, authorities, going to the traditional authorities where people are, so that we limit them going to the cities and causing the load reduction.
I think it's a fair comment. It's not a question, it's a comment,
Yeah.
and I agree with that comment.
Okay.
I think it's something that we need to look at. I agree.
Thank you
Yes.
very much. Can I, Jacob, may I ask you a personal question? Are you a member of the ANC? No, don't answer. Now, I thought perhaps if you were, we could nominate you as president for the views and the long-term plan. Thank you very much.